On October 2nd, something amazing happened in the sky of Mars. Something fast, incredibly fast, raced through space. An amateur astrophotographer named Stephen Burns noticed it in the raw images of the Perseverance rover published by NASA. He created a time-lapse, 9 minutes of data compressed into one clip. And there it is. The object moved at 60 kilometers per second, contrasting with the usual movement of stars. But here is what is strange. Other users also began analyzing the same images and claimed to see several objects, many rapidly moving anomalies on the data from October 3rd, plus a mysterious green flash that no one can explain. NASA planned an observation. Several Martian orbital spacecraft were set to capture the closest photographs ever taken of an interstellar object. A high-resolution camera capable of taking pictures with a resolution of 30 kilometers, such as Mars Express. The ExoMars Trace Gas Orbiter. Everyone was focused on the target 3I Atlas during its flyby on October 3rd, and then silence. No official images, no data, nothing. Meanwhile, Avi Loeb from Harvard has just published something that puts the entire astronomical community in an awkward position. This object, 3I Atlas, may have been the source of the famous WOW signal of 1977, with a probability of coincidence being 0.6%. But the connection with the WOW signal is just the beginning, as 3 comets are breaking all known rules of behavior. They produce industrial-quality nickel alloys in space. Their tails point in the wrong direction. It is green when it shouldn't be green, moving along a trajectory perfectly aligned with our planets. The odds of something like this are astronomical. Some call it the largest interstellar object ever discovered. Others consider it impossible. Avi Loeb considers it potentially artificial, currently hidden behind the sun, approaching its closest point to our star. What will happen when it reappears? Before diving into the details, if you're interested, please like and subscribe to not miss future events, and comment where you're listening from, what time it is there, and whether you think we're observing one object or several. If you want to help the community grow, share this on social media. Thank you for your support. Chapter 1. Wait, there are a few objects. Let's return to October 2nd. Stephen Burns was not looking for anything unusual. He was simply processing the raw images made available to the public by NASA from the Perseverance rover. The rover was tasked with observing the night sky during a specific time interval when the 3 atlases were expected to pass closest to Mars, a relative distance of 29 million kilometers. Burns took 9 consecutive shots and compiled them into an animation. In astrophotography, this technique reveals movement that would be invisible in a single frame. The stars appear to move across the frame due to Mars's rotation. But it was different. Something crossed this movement at an angle that made no sense to the background star. The speed was the first hint. 3 Iota Atlas moves at 60 kilometers per second, faster than almost anything in our solar system. In comparison, Earth orbits the Sun at about 30 kilometers per second. The Parker Solar Probe, the fastest human-made spacecraft, reaches 192 kilometers per second only at its closest distance to the Sun. However, Tri-I Atlas maintains this incredible speed throughout its journey. Burns published his animation online, and within hours, other astronomy enthusiasts began their own analyses. It was then that someone named Naktafe, which translates from German as night monkey, made a statement that sparked a wave of discussion in the observational community. In photographs from October 3rd, Naktafe wrote that several comets could be seen. Not one object, but several. Another user, Alexander Ferrum, pointed out something else. What is the flash at 2 seconds 003, marked in green? Go back and watch the Burns animation frame by frame. At the 3rd second, a brief green glow appears. This is not a camera artifact. This is not a cosmic beam that appears as a single bright pixel. It is a diffuse glow, localized yet distinct. The green light in space has specific causes. On Earth, we associate it with the northern lights, the burning of copper, and certain bioluminescent organisms. In space, the green glow usually comes from oxygen or a molecule called dicarbon. 2 carbon atoms bonded together. Comets sometimes glow green when solar radiation excites dicarbon in their comas. But here lies the problem. The spectroscopic analysis of Tri-I Atlas with a very large telescope showed almost zero content of dicarbide. This object, as astronomers call it, is depleted of carbon chains. It should not glow green. Nevertheless, photographs from ground telescopes in early September clearly showed a greenish tint around the object. The green flash in the images of Mars, if real, adds another layer of mystery. As for these few objects, speculation begins here. But the speculations come from people with telescopes and image processing software, not from those who invent. When you stabilize the star field in Burns's animation, considering the rotation of Mars and the movement of the main object, at least one or two additional points of light appear, moving at different speeds. Could these be image artifacts? Certainly. Could these be background asteroids that just happened to be in the frame? Perhaps. Could these be separate fragments or even smaller objects accompanying Tri-Eye Atlas? That's a question no one can answer yet because NASA has not published the data. A high-resolution camera of a Martian reconnaissance orbiter observed Tri-Eye Atlas from 1 to 4 in the morning, local time on Mars, on October 2nd. The Gas Monitoring Orbiter and Mars Express both made observations on October 3rd. These were not random shots. These were coordinated, pre-planned scientific observations aimed at obtaining the highest resolution data about an interstellar object. HiRACE, an experiment in high-resolution imaging, can distinguish details up to 30 centimeters on the surface of Mars from orbit. As he heads towards an object located 29 million kilometers away, he still needs to ensure a resolution of about 30 kilometers per pixel. This means that if the three-eyed Atlas object has a core 5 kilometers in diameter, as recent estimates suggest, it should appear as a bright cluster of pixels in high-res images. It is more important that this tool can distinguish a compact core from a fragmented or multi-component object. If there are several parts, if there is an accompanying object, if there is something unusual in the structure, HiRACE will capture it. So where are the images? NASA's official statements were minimal. The Martian orbital probe successfully conducted its observations. Data is being processed. Updates will be provided as analysis continues. This happened more than 24 hours ago. In the world of space visualization, 24 hours is enough time to at least familiarize oneself with the raw data. Some observers noted that the United States government dealt with various administrative issues that affected the publication of scientific data. But ESA works independently. They should not have such restrictions. However, ESA images also did not appear. Silence feels deliberate, and when official channels fall silent, amateur observers begin discussing the situation. Because here is what we know, for sure. The Perseverance rover has indeed captured something. Several amateur analysts studying the same available data noticed anomalies. An object or objects moved at speeds corresponding to the three eyes of Atlas, and there is that green flash that no one can explain. What we do not know is the reality of these supposed multiple objects, whether they are separated from the main comet, and what NASA and ESA have seen with their more powerful instruments. On October 3rd, the flyby became the closest a spacecraft has ever approached an active interstellar object. This was our chance to understand what the three-eyed Atlas really is, to see its structure up close, to determine whether it behaves like an ordinary comet or something entirely different. And while we wait for answers, the object continues its journey. Right now, he is approaching the Sun, delving into the inner solar system, where ground-based telescopes lose sight of him due to sunlight. By the end of October, it will be behind the Sun from our viewpoint, completely hidden, and when it appears in November or December, it will either confirm all natural explanations or do something that comets simply do not do. But before he disappears, we need to talk about what was really sought in the observations of Mars and why this silence matters more than you might think. Chapter 2. A black screen on Mars. There is a certain pattern in how space agencies handle sensitive observations. When something familiar is recorded, data appears within hours. Images of the rover are uploaded to public databases. Press releases are published. Scientists share their findings on social media. But when something unexpected happens, silence follows. The technical explanation for the delay is related to data processing and calibration requirements. Mars orbiters do not transmit images in real time. They store observations on board and then transmit them to Earth during scheduled communication windows. After that, the data undergo various processing stages: geometric correction, radiometric calibration, noise filtering. For a typical observation of the surface, it takes 6 to 12 hours, and for removing a target object against the star field, possibly twice as long. We have long exceeded 48 hours since the observations of October 3rd. But there is another factor that is not mentioned in official statements, but permeates the community of researchers who depend on NASA data for their work. Budget constraints and administrative failures have created bottlenecks in data release protocols. This is not a formal stop, but rather bureaucratic friction that turns familiar processes into delays. Employees work reduced hours, priorities are redistributed, and verification chains are lengthened. Yes, it operates within different administrative structures, but images from Mars Express and ExoMars Trace Gas Orbiter have not appeared either. This indicates that either a coordinated decision was made to suspend preliminary data until a full analysis is completed, or both organizations are simultaneously facing technical difficulties. The question is, what could be so complex as to cause such a delay? Think about what these tools were created for. A color stereo system for capturing the surface of Cassis on the Trace Gas Orbiter can distinguish objects as small as 4.5 meters per pixel while imaging Mars. When it comes to a comet located 29 million kilometers away, the resolution significantly decreases, but the instrument's sensitivity remains high. It is designed to detect subtle color variations in the materials of the Martian surface. If 3 groups of Atlas were to drop various types of ice, and if their clumps showed composite variations, and if there were structurally different areas, Cassis would have recorded it. Mars Express is equipped with a high-resolution stereo camera that, despite its name, focuses on 3-dimensional topography. For a distant comet, its stereo capabilities are less important than the ability to capture images simultaneously in multiple wavelength ranges. The camera can distinguish dust, water ice, carbon ice, and various minerals depending on how they reflect different colors of light. And then there is the Mars Reconnaissance Orbiter with its high-resolution instrument, High-Resolution Imaging Science Experiment, which we mentioned. But here is what we have not discussed yet. The High-Altitude Observer not only takes pictures but collects data across 3 color ranges: blue, green, red, and near-infrared. When the apparatus is aimed at the comet, these ranges help reveal different aspects of its compositional activity. Blue and green light interacts with gases in the coma, while red and near-infrared penetrate through the thin dust, revealing the structure beneath. If a comet ejects streams of material from specific spots on its core, and if these streams have different compositions, and the brightness of the objects varies in a way that indicates a heterogeneous surface, a high-altitude observer will record all of this. However, it is important to remember that sensitive images sometimes reveal details that require further consultation before publication, not due to any conspiracy, but because preliminary observations can be misinterpreted without proper context.